Continue with question 2, tutorial 5. Okay, consider the following reaction scheme. Illustrate a structural formula of compound C, D, E, and F. Okay. Okay. Illustrate structural formula for compound C, D, E, and F. Structural formula. So, to illustrate the structural formula means that this question asks you to draw the structural formula for both compounds. So, what you need to do is you need to identify the reaction involved to produce this compound, which are C and D. Okay, what is this react with acyl halide in the presence of aluminium trichloride. Here is Fieldcraft acylation. Fieldcraft acylation. Okay. Fieldcraft acylation. Okay, here what happened here? This, what is the function of Cl? Cl is autopara director. So, it will direct the acyl group to the location auto and para. So, the answer is auto. C double bond O C3 plus one, two, 1, 2, 3, 1, 2, 3, 4. C double bond O CH3. So 1, 2 and 1, 4. This is compound for compound C and here is for compound D. Okay, reaction involved. Okay, we hold first. So let's take a look of structural formula for compound E. Okay, what is the structural formula for compound E? Okay, let's see the hint for this type of question. So it state here sulfonation. Okay, when sulfonation, it normally produce SO3, SO3H. Am I right? You still remember? Sulfonation. So it will produce SO3H, which is normally when benzene react with sulfur trioxide in the presence of sulfuric acid, so it will produce benzene sulfonic acid. However, in this question, it has nitro substituent on the benzene ring. So what is the function of this nitro group? So the function is it will direct the location SO3H to the location meta, because NO2 is M director. So it will direct location SO3H to the location meta, which is 1, 3. So the answer is NO2. So it will be 1, 2, 3. 1, 2, 3. So it will be SO3H. 1, 2, 3. Okay. Then for F, Cl2 in the presence of sunlight or UV, UV light. So normally when it state the reagent Cl2 in the presence of sunlight or UV light, normally it will referring to the reaction at side chain. It only happen at side chain, which is happen at substituent, not on the benzene ring itself. So this involve the radical halogenation on the side chain. So the answer is, so one hydrogen here is substitute with Cl. So the number of hydrogen here is reduced to 2. One hydrogen here is substitute with Cl. Okay, this is the answer for F. Then the question asks you to identify the reagent 1 and 2 including the condition, if any. Condition tu maksudnya katalah macam anak panah kan. So macam ni anak panah. Here is reagent. Here is condition. Condition tu maksudnya is it dia heated ke, high temperature ke, temperature dia berapa ke, is it dia dalam acidic condition, basic condition, yang tu. Okay, yang tu kita panggil condition. pH dia tu semua condition yang tu. Okay, so what is the reagent and condition for reagent 1? So here, from benzene, it produce this product, which is a nitrobenzene. What is the reaction that involve that add nitro group on the aromatic compound, which is on the benzene itself? So it is nitration reaction. So the reagent is HNO3 in the presence of sulfuric acid. Means that the reagent is nitric acid and the condition is in sulfuric acid, which is in strong acid with the low pH. Sulfuric acid, this is the condition. And for the reagent 2, okay, from benzene produce toluene. Okay, what is the reaction that add alkyl group on the benzene ring? So do you still remember? Friedkraft alkylation. Friedkraft alkylation is a type of electrophilic aromatic substituent that add alkyl group or we call as that substitute hydrogen on the benzene ring with the alkyl group. So the answer is reagent is CH3Cl in the presence of aluminium trichloride that act as a catalyst. If you use here Br, here also Br. Okay. So here is we already solved for question A, B. Then for question C, the question asks you to identify the name of reaction Y. Where is the reaction Y? Reaction Y is Friedkraft acylation. And outline the stepwise mechanism for the reaction of benzene with reagent 2. So this question wants you to outline the stepwise mechanism. When the question states stepwise mechanism, so you need to show the electron flow. What is the meaning of the electron flow? Means that in your reaction, you need to show how many electrons involved, the electron flow, the arrow, the resonance involved. Okay. I will show you. Question 2D. Tutorial 5. So the question asks you to outline. Normally, for the question like this, it will contribute around 5 to 8 marks. Stepwise mechanism. Kalau mechanism, you kena tunjuk in detail lah. Bukan macam synthetic sequence, give the reaction, general equation, semua tu tak perlu tunjuk. Electron flow semua tu. Reaction of benzene and reagent 2. So, okay. Okay. To show the stepwise mechanism, okay, you have here method 1. So let's say we first we write down the general equation or general reaction. Okay, benzene react with what? Reagent 2, right? React with CH3Cl in the presence of aluminium trichloride to produce CH3. CH3 plus HCl plus AlCl3. So basically this is the we call as general reaction of Friedcraft acylation. Okay, so we proceed with step 1. Okay, step 1 is the formation of electrophile. Okay, let's see here. This CH3Cl so react with aluminium trichloride. Okay. So what happened here? So it has 2, 4, 6, 8. So what happened here? This 2 electron will attack this aluminium and it will form a bond. So it will become like this. It will form a bond with catalyst. So what happened here, when this aluminium accept the electron, so it will be more negative. So when this chlorine donate an electron, it will be positive because it lost its electron. Then we have 2 electron here, right? So these 2 electron will give to this chlorine, and then bond will break here, so it will become CH H and H. So when this carbon lost its electron, it will become positive. And at the same time, when this chlorine accept these 2 electron, before this, its behavior is positive. When it accept 2 electron that exhibit a negative behavior, so positive, negative, then it will be neutral. So Cl will be neutral. This Cl will be neutral. However, for aluminium, it's still in negative charge. Then we proceed with step 2. So step 2, the benzene ring will react with carbocation that you produce at method number 1. So here, okay, always remember, nucleophile will attack electrophile in the mechanism. Why we call benzene as a nucleophile? Because benzene contains lots of electron here. Means that any species that contain more double bond, so of course it also contain more electron. So the species that contain more electron, so we categorize as a nucleophile. So in the mechanism, the rule is nucleophile always attack the electrophile. So that's why the arrow like this. Like this means that this will attack this. Okay. Then you will get so here will become positive because it lost its electron. Then for resonance structure, basically this electron can delocalize in this ring like this. These 2 electron move to here, so it will become like this. So here will be positive charge. Then another type of resonance, this electron move here. When this electron move here will be positive because it lost its electron. Positive here. Okay. So we call here resonance stabilize carbo cation intermediate. Resonance stabilize carbocation intermediate. So kalau tadi kan saya terang berkenaan rate of reaction kan. Yang ni dia akan kacau yang ni lah. Sama ada dia akan stabilize ataupun destabilize. Proses ni kita panggil resonance stabilize. Benda ni lah kita panggil resonance stabilize carbocation intermediate. So then you tak perlu tunjuk semua. Kata kita pilih. Kata kita ada resonance A, yang ni resonance B, yang ni resonance C. Okey, katalah kita nak resonance A saja. So what happen here? Yang ni adalah resonance A. Kan? Resonance A. This resonance A will react with aluminium tetrachloride that you produce at step 1 before this. Okay, this we have 2 electron. These 2 electron will be given here. Then bond will break. What happen? This hydrogen will combine with this HCl. Bond will break here. 2 electron move to here. So you get plus HCl plus AlCl3. Then your mechanism is complete.